I'm going to present the work under the title Development and Evaluation of a Duplex Lateral Flow Assay for the Detection and Differentiation between Rabbit Hemorrhagic Disease Virus and Rabbit Hemorrhagic Disease Virus 2. This work was performed within a European project, the VetBioNet. First, we described three main objectives. One, the development and selection of monoclonal antibodies for the specific recognition of both variants of the virus. Second, the development of the duplex lateral flow assay that allows the differentiation between rabbit hemorrhagic disease virus and rabbit hemorrhagic disease virus 2. And third, the prototype evaluation. First, the determination of the analytical sensitivity using recombinant virus-like particles, VLPs, and then the determination of the diagnostic sensitivity and specificity using two types of samples, liver samples and liver exudates. Regarding the first objective, the development and selection of monoclonal antibodies for the specific recognition of both variants, mice were immunized using VLPs, virus-like particles, based on the viral protein 60 of Rh-DV2. And then those mice were immunized using a peptide of the same protein conjugated to ovoalbumin. A set of 10 different monoclonal antibodies was obtained, and they were characterized using indirect ELISA to study their specificity. 5 of them were specific for Rh-DV2, and the other 5 commonly detected both variants of the virus. Then the isotype was also determined, and the immunofluorescence was studied in 3 cases, the 3 most promising antibodies. Here in the right, you can see an example of the immunofluorescence of the monoclonal antibody 16F12. In the picture in the right, the cells had been infected using the VLPs of Rh-DV2, and you can see the immunofluorescence, and also the absence of that immunofluorescence in the case of the picture in the left, where the cells had been infected with virus-like particles of Rh-DV. And also, furthermore, a previously obtained set of monoclonal antibodies that recognized both variants were also studied. For achieving the second objective, the development of the duplex lateral flow assay that allows the differentiation between 2 variants, the selection of the antibodies and the conditions was studied. The best antibody pair was composed of the monoclonal antibody 16F12 that is specific for the detection of Rh-DV2, and another antibody, 2E11, that commonly recognizes Rh-DV and Rh-DV2. Furthermore, the conjugate nanoparticles, the assay format, the running buffer, membrane, and all the materials involved were studied, and the best ones were selected. The test procedure was established in three different steps. First, the sample preparation, because if the sample is a liver, it must be homogenized and subsequently extracted using the extracting buffer, and if it's a liver exudate, no sample preparation is needed. Then, as the second step, 20 microliters of the extracted liver or the exudate must be added to the sample window of the device, like in this drawing. And then third, 3 drops of running buffer must be added to the same window. The results are read after 10 minutes. For reading the test, we have here in the right an example. When the sample is negative, only the control line, the blue one, appears. If the sample is positive for Rh-DV, the control line, but also the T1 appears, the red line in the middle. And then if the sample is positive for Rh-DV2, the 2 test lines appear, T1 and T2, but if the sample contains low viral burden, only T2 line appears. Then the prototype obtained was evaluated, and first the analytical sensitivity was determined using VLPs of Rh-DV in blue in the graph and VLPs of Rh-DV2 in orange in the graph. As depicted in this graph, the sensitivity of the VLPs of Rh-DV2 is higher than the ones of the VLPs of Rh-DV. The limit of detection of the duplex is lower for the VLPs of Rh-DV2 than for the VLPs of Rh-DV, detecting 0.08 micrograms per ml and 0.02 micrograms per ml respectively. Once the analytical sensitivity has been determined, the diagnostic performance was studied, employing both liver samples and liver exudates. Regarding the first type of samples, liver samples, they were classified previously by RT-PCR, and a set of 96 liver samples was studied. The sensitivity obtained for the detection of RHDV was 91.3%, and the sensitivity for the detection of RHDV2 was 95.5%, a bit higher. And the specificity in both cases was 100%. Regarding the liver exudates, they were also classified by RT-PCR, but in this case, only negative samples and positive to RHDV2 could be studied. The sensitivity for the detection of RHDV2 was 95.8%, and the specificity was also maintained at 100%. Based on the results obtained, the following conclusions can be drawn. First, a set of 10 monoclonal antibodies have been obtained and characterized. 5 that commonly recognizes both variants of the virus, and 5 that are specific to RHDV2. Second, a new duplex lateral flow assay that allows the differentiation between both variants has been developed using 2 selected monoclonal antibodies. Third, the analytical sensitivity of the developed test is 0.08 micrograms per ml of the VLPs of RHDV and 0.02 micrograms per ml of the VLPs of RHDV2. 4. The diagnostic sensitivity and specificity was determined using liver samples and liver exudates, yielding a sensitivity of 93.8% and 95.8% respectively, and a specificity of 100% in both types of samples. 5. When considering the 2 cohorts of different types of samples as a whole, the reached sensitivity was 94.4%, whereas the specificity was maintained at 100%. And 6. The developed duplex lateral flow is a suitable tool for the detection and differentiation of both variants of the virus that could be used as a reliable first assay for the surveillance of rabbit hemorrhagic disease. And finally, I would like to thank all the people involved in this work: Esther and Juan from INEA in Spain, Ghislaine and Cécile from ANSES in France, and to my colleagues at Eurofins Ingenasa, Paloma, Mercedes, Istar, Isabel, and Elena. And here you can find my email, just in case you have any doubts or any comment that you want to share with me. Thank you for your attention.